Sometimes in math we have to deal with these things called negative exponents. So this first example, you notice we have our base of x, but now the exponent is negative. 95% of the time you do not want to leave a negative exponent in a final answer, so we have to know how to deal with this. You need to have your exponent positive, so what do we do? So there's a property for negative exponents. I'm going to just kind of show you the shortcut through the property. Basically what it says is this is a fraction right here. It's already over 1, so if we view it as a fraction, that helps us out a little bit. So if you need to change the sign of your exponent, right now it's a negative 5, we want that to become a positive 5. So the exponent and its base, you grab the exponent with its base and you move it. If it's in the top, we're going to move it to the bottom. If it was in the bottom, we'd move it up to the top. So what happens is that x to the negative fifth got moved down to the bottom. The base stays the same. The x is never going to change. It's only the exponent that will change signs. It was a negative 5, and now it becomes a positive 5. And then we say, well, what do we have left up top? The only thing that was up there was the x to the negative 5. Everything moved down, so we leave a 1 in its place. So 1 over x to the positive 5 power. So basically, if you move an exponent with its base throughout a fraction, it will change its sign. So m to the negative 3, it is over 1 already. It's a negative exponent. We want that positive, so we're going to move it. So we take the exponent with its base. It's coming down here. So the m stays the same. The negative 3 changed signs. It becomes a positive 3. Then what do we have left up top? Just the 1. So we have 1 over m to the third power. Alright, moving along. These two examples are a little bit different. Not too bad once we know how to work with them. We notice that we have a negative exponent. Again, let's make sure we understand this is over 1. So it is a fraction we're dealing with. And that n to the negative 8, we need that negative 8 to be positive. One thing I want to look at for a second, the 2, the coefficient out front, it has its own exponent that they just didn't write in for us. Really, it's a 2 to the first power. And because that 2 to the first power is positive, it's a positive 1, we do not need to move the 2. So what you do is you find your negative exponent and you grab the base that goes with it. That negative 8 only goes with the n. It doesn't go with the 2 because the 2 has its own exponent right there. So you take the n to the negative 8, we're going to move it because the movement makes that positive. So on the bottom we have n to a positive 8 power. And what do you have left up top? Well, the 2 to the first didn't move, so that 2 to the first, or just 2, stays up there. So you can separate the 2 and the n to the negative 8th and move only the thing that has the negative exponent. Alright, last example, same idea as the one we just did. You have the 4 to the first power that's positive, so it's not going to go anywhere. Your p to the negative 2, there's your negative exponent. So you grab the exponent with its base, we move it so that that movement makes that a positive squared. And what stays up top? That 4 to the first power, or just 4. And those are your negative exponents. Video 1. There's another one coming.